Hello, guys. Today we are starting a brand new unit, and my computer's being slow. This is your warning. Our unit is topic 2, and it covers integers and rational numbers. And the first lesson we're going to do, which you're watching right now, is understanding integers. And this is a pretty long, hefty lesson. So if you're watching this recording, you may be watching the whole lesson, whereas in class, I'm not sure how much we're going to get through. So today, we're going to be understanding integers. We have a really long to-do list in order to be successful. The first thing we have to be able to do is define integers. So that's one of our main vocabulary words. But we have a lot of other vocabulary words. We also want to be able to plot integers on vertical and horizontal number lines. So remember, vertical is up and down, horizontal is like the horizon. So we want to be able to plot integers on number lines. We want to be able to identify opposites of integers. We want to be able to compare and order integers, and then we want to use them in real world situations and explain what 0 means in that context. So we have 5 main vocabulary words that are going to be important to your success in today's lesson. So we've got a lot to be able to do in order to be successful. So let's get started. The first thing we're going to do is a bell ringer. And this bell ringer could be pretty tricky because it's already asking you about integers before we even do the lesson, but it wants to get our brain kind of going for today's topic. So it deals with temperature. It says Sal recorded the outdoor temperature as -4 degrees at 7:30 in the morning. At noon, it was 22 degrees. Okay? And this is like what happens every day. This morning we woke up and it was really, really cold, but as the day goes on, it warms up. So it started at -4 and it went to 22. Sal said the temperature changed by 18 degrees. That's what Sal says, because when you subtract 22 minus 4, you get 18. Our job is to figure out, is Sal right or wrong? So in class, we did a poll. Since you're watching the recording, you're going to have to look at the information, look at the thermometer, the temperature gauge to help you, and decide, is Sal right or wrong? So pause it and figure that out. All right, so let's use this temperature gauge to help us. Let's plot where these numbers are. So -4, negative means it's below 0. If I count down 4, 1, 2, 3, 4, that puts me right above -10. That doesn't seem right. There's not 10 tick marks here. They must be using a different scale. Let's check and see if they're counting by 2s. 2, 4, 6, 8, 10. They are. Always check your scale. So -4 would be, go from 0, -2, -4. This dot right about here is -4. Now, it goes all the way up to 18. So here's 10, 20. Nope, it doesn't go up to 18. It goes to 22. Silly me. Let me use purple again. It goes up to 22. So 10, 20, 22. So this is what we're looking at. Our temperature started at -4, and then it went all the way up and stopped at 22. So let's see here. 0 is the dividing line between positive and negative. Okay, 0 is neutral land. It's the dividing line. So I went from -4 up to 0. So from -4 up to 0 it rose 4 degrees. Do you guys agree? To go from -4 up to 0, it had to go up those 4 degrees. Then once it was at 0, it went from 0 to a positive 22. So it went up 22 more. So it started below 0. It was 4 below. It went up to 0. That was 4 spaces up. And then it went up 22 more degrees. Well, you have to add those together, not subtract. The temperature went up 26 degrees. So Sal, our friend Sal over here, he was wrong. He subtracted them because he thought change meant difference, which means subtract. But really, we were working on opposite sides of the number line. Okay, it had to go up 4 degrees first. Up means add, and then up 22 more degrees. Okay, so that is an example of how to use integers in the real world. Integers are the numbers we dealt with: 18, 22, -4, 26. All these numbers on our number line. Integers are positive and negative whole numbers, and it also includes 0. So we're going to get to know integers a whole lot more. The first thing I believe we're going to do is we are going to watch a video. Yep, so get your popcorn ready. Here we go. I'm going to try to make it so you can hear it, so bear with me. Oh, I have to play it. Sorry.
What are integers? Think about this question during the lesson. The counting numbers, their opposites, and 0 are integers. Numbers that are located on opposite sides of 0 and are the same distance from 0 on a number line are opposites. You can extend a number line to include negative numbers. What integer is the opposite of 6? To answer this question, first consider the following. Why do you think it is important to include negative integers in our number system?
Okay, so why do we even have negative numbers in our number system? Well, it's because in the real world, everything's not positive. You saw from the bell ringer question, sometimes the temperature's below 0. Sometimes the wind chill is -11 degrees and they cancel school. Sometimes you go into debt. You don't have any more money and you actually spent more than you have. Your bank account is negative. In football, when you lose yardage, you can go negative. So in the real world, we have positive and negative numbers. So in our number system, we have to have negative numbers to represent those situations. Is it going to play? I told you guys my computer was going slow.
Negative integers are used to represent situations less than 0, like temperatures below 0. What is unique about 0?
Okay, 0 is a very special integer because integers are the positive and negative numbers, right? But 0 is not positive or negative. When you look at this number line, you can see they have negative numbers labeled. They have positive numbers labeled, but 0 is just in the middle chilling. 0 is not positive or negative, but it's still an integer. It is the center part of our number line.
0 is neither negative nor positive. It is its own opposite. Here is one way to think about the opposite of 6. A thermometer is like a vertical number line that uses integers to show temperatures measured in degrees. 0 represents 0 degrees Celsius. 6 degrees Celsius is 6 degrees Celsius warmer than 0 degrees Celsius. Negative 6 degrees Celsius is 6 degrees Celsius colder than 0 degrees Celsius. The integer -6 is the opposite of 6. If the opposite of 6 is -6, what is the opposite of -7?
All right, so that part of the video used a lot of the word Celsius, so they might have confused you a little bit. So what we have here is we just have 6, -6. Those are opposites. One has a positive, one is a negative, but they're the same root number. So I have a -7. The opposite of -7 still has to have the same root number, but where one's negative, the other's positive. So -7 is the exact same. 0 doesn't have the same root number. 7, the numbers match. One is negative, one is positive. The opposite of -7 is 7.
What is the distance from 0 to negative 7 on the thermometer? What is the distance from 0 to 7 on the thermometer? What can you conclude about the two distances from 0? The distance from 0 to negative 7 on the thermometer is 7 units. The distance from 0 to 7 on the thermometer is 7 units. The distances from 0 to a number and from 0 to its opposite are equal.
Okay, so you may not have heard everything they said because I didn't move the mic back. They're talking about distances, and it seems like I've lost my writing tools. I don't know where they went, but it's saying that negative 7 is 7 spaces below 0. Positive 7 is 7 spaces past 0. Opposites are the same distance from 0. Okay, it could be negative 1 and positive 1. They're one above and one below 0. Okay, so they're the same distance from 0. So if we have negative 40, what do you think the opposite is? Positive 40, because they're both 40 from 0. If we have positive 10, what do you think the opposite is? Negative 10, because they're both 10 away from 0. Okay, so 50 and negative 50 are opposites because they're both 50 away from 0. 50 below, 50 above. So one's positive, one's negative. All right.
Here is another way to think about the opposite of 6. The opposite of a number is the number itself. For example, the opposite of the number 6 is negative 6, and the opposite of negative 6 is 6. You can write this as negative 6 equals 6.
All right, so that might have been like, say what? So I need to find my writing tools, and it seems like I've lost them, guys. Where are my writing tools? Here they are. I want to show you what that means. So if you have 6, the opposite of 6 is negative 6. That's pretty easy. That makes sense. But sometimes you're going to see things written like this. You have a negative parenthesis negative 6. What this means is it wants the opposite of a negative 6. You want an opposite of a negative 6. Well, what's the opposite of a negative 6? A positive 6. So in math, when you see two negative signs next to each other, it means make it positive. Two negatives make it positive. Okay, so let's do another one because that's just a weird concept. But it's important for 7th grade. Say you have negative 3. Okay, negative 3. It means the opposite of negative 3. So what's the opposite of negative 3? Positive 3. Remember, two negatives make a positive. All right, so now what we're going to do is we are going to put these skills to use. I'm going to do one example with you guys, and then you guys get to practice your skills, and in class we're using Pear Deck. So here's an example of some skills you're going to have. We need to label integers. Remember, we want to define integers. Well, integers are the positive and negative numbers and 0. Okay, so I want to label the integers on the number line. Let's start in the middle. The central number on a number line between a positive and a negative 1 is 0. Okay, this goes up to 5, so I think we're counting by ones. Let's check. 1, 2, 3. Well, this must be a 4, and there's a 5. When you count negatives, you just count backwards. Negative 1, negative 2, negative 3. Oh, well, this is a negative 4. Look, I plotted integers on a horizontal number line. Opposites. Well, the opposite of 4, it's going to have the same number, and if one's positive, the other's negative. So the opposite of 4 is negative 4. The opposite of negative 4 is a positive 4. Look right there. I defined integers, I plotted integers, and I identified opposites. And then it says, how do you know that two numbers are opposites? Well, how would you explain that? I would explain it as they both have the same number 4, one's positive and one's negative. You could also say opposites are the same distance from 0 on a number line. 4 is 4 hops away from 0 to the right, and -4 is 4 hops away from 0 to the left. They're both 4 spaces from 0. So there's 2 different ways to explain how you know that 2 numbers are opposites. So now that we've kind of tried an example of a math problem using integers together, what you guys are going to do is you're going to try an example kind of on your own. In class, we're using Peer Deck, okay? And this is an interactive slide. Since you're watching the recorded version, you're just going to kind of think in your head what goes here. So we want to know what this missing number is. So think for a second, what is this missing number? Be careful of the scale. Every tick mark is counting up by 2s. 2, 4, 6, 8, 10. So when I go backwards, 2, 4, that should be a 6. But since it's to the left of a 0, it should be a negative. So if you got -6, you're perfect. Okay, -6 is perfect. Let's go to the next slide. So this one wants us to pick all of the following that are opposites of 12. Okay, so here are some options. Since you're not doing the peer deck, you can't see the options. But here are some of the options. Which of the following are the opposite's a vocabulary word, of 12? Take a second and think. All right, let's go through them. 12 is not the opposite of 12. It's the same. -12 is the opposite of 12. Same number, one's positive, one's negative. The opposite of -12, well, that's a positive 12. Remember, 2 negatives make a plus. So positive 12 and positive 12 are the same. This is just a -12. It just has parentheses around it. So these two are the opposite of 12. Okay? Opposite. Same number, one's positive, one's negative. But sometimes that negative's in disguise. Or that positive's in disguise. So let's try another one just like that, dealing with opposites. Okay, this one wants to pick all the ones that are opposite of -5. So we have 5. We're going to have parentheses -5. We're going to have this. And I feel like I'm missing one. We'll just use this like that. All right, so which of these do you think are the opposite of -5? Pick all that apply. Okay, so this is negative, so I need the positive. 5 is the opposite of -5. This is just a -5. It's the same, not the opposite. The opposite of a -5, 2 minuses make a plus. This one's the opposite because it's really a positive 5 in disguise. Opposite of -5, and I'm looking for the opposite of -5. -5 and -5 simply match. You should have picked the first and the third. Okay, and the next one wants us to match opposites. And in class, the students were able to draw on their screens because Peer Deck is interactive. But since you're watching the replay, you cannot. So what it wants you to do is connect opposites. So in your head, go ahead and connect them or on a piece of paper. You can pause it if you need to. All right, some of them are pretty easy. Like 8 and -8 are opposites. 19 and -19 are opposites. But then I have a bunch of 24s. So I know 24 and -24 are opposites. That leaves these two to be opposites. But why? Well, because this says opposite of -24. This is the opposite of -24. And you can remember 2 negatives make a positive. So these ones connect. Opposite numbers. Okay? And if you have any questions, make sure you come to office hours around 1:15 to 3:30. Sometimes I'm a little late because I'm switching computers. So if I'm not there exactly at 1:15, give me about 5 minutes. All right, now we're going to do example 2 from Savas Realize. Remember, these are our goals. These are our goals. We're going to define integers, plot integers, and identify opposites. We might even compare and order. So I need to go to Savas Realize, example 2. Bless my slow computer. All right, so it says Riley recorded the temperatures for 5 days in January. So these are the temperatures he recorded. It wants to know which day was the coldest day, which was the warmest day, and then write them from least to greatest. All right, so what it gives me are these boxes that I can drag. So let's see, this dot right here is between -4 and -6. So that should be -5. Because remember, I count backwards. This is a 1, but it's got to be negative because it's the left of 0. I don't have that option. -2, it's right here. -3, and I already did -5. So go to the right. These are positives. 1, 2, 3, 4. When you put integers on a number line, they are automatically in order for you. So this is the least, and this is the greatest. So the warmest day was 4. Warmest day, 4. The warmest day was Wednesday. The coldest day is -5. That was Monday. And my numbers are already in order from least to greatest for me. Okay, so this is how you organize and compare integers. You put them in a number line. A number line will put them in order. The least is always to the left. L for least, L for left. The greatest is always to the right. Okay? So let's see if we can put that to use. So we just talked about comparing and ordering. So I want you to think about this question. Which of these two numbers, if you use a number line, is the greatest? Is -4 the greatest, or is -2 the greatest? So here's a number line. Remember, L for less, L for left. So left, these are the least. Okay, right is the biggest. So think about this. So what'd you get? -4 or -2? The number that's greater is -2. Because here's 0. Here's 1, 2, 3, 4. Count backwards. -1, -2, -3, -4. So if I were to put, I guess I want to use red. If I were to put -2 right here and -4 right here, -2 is greater because it's further to the right. The numbers that are to the right are the bigger numbers. -4 is the least because it's furthest to the left. It's the furthest below 0. So you need to remember left is least or left is less, whichever way you want to think about it. And the numbers to the right are the bigger numbers. Okay, so -2 is actually bigger than -4 because it's further than the right. -4 is further below 0, so it's smaller. Okay, let's try another one. Erase, erase, erase. Okay, this one wants you to plot each number. So in class, they were able to drag these dots. They were able to take the dots and they were going to drag them where they go. If you're watching it recorded, I just want you to think about where they go. Okay, or you can draw a number line on your paper. So pause and do this question, please. Oh my goodness, my computer screen is possessed. All right, so this one, it's grayed out for some reason, and I don't know why. But for this one, -10 is right here. Why is my screen blue? Is my computer about to die? G is at -10. That one was pretty easy because it was labeled. The rest of these don't have an exact label, so I have to be more careful. So 8. Goodness gracious. 8, +8. Well, let's just count. 1, 2, 3, 4, 5, 6, 7, 8. This is where 8 should be. So I'm going to put an H. Okay? -1, it's negative, so it goes behind 0 and just one space behind 0. That's I. 6, well, here's my 5. It should be 1 after 5 because 6 comes right after 5. -3 is negative, so I need to go backwards. 1, 2, 3. If I go backwards 3, I end up at -3. So I just plotted. Remember, plot is a vocabulary word. Plot. Put a dot in a label for each of those integers on a number line. Okay, now I have no idea why my screen is blue. If my computer dies, I am so sorry. I feel like I've had all the technology issues this morning. Okay, let's try another one. Writing these in order from least to greatest. So I want you to pause your computer or your video and see if you can put these in order from least to greatest. Least to greatest. Oh, it turned blue again. All right, so least is most negative. The number that is most negative is going to be -8. Then -5 is going to be the one that is most negative after that. So negative numbers kind of go backwards, okay? Backwards of what you would think. Positive numbers, the smaller out of those two is 6. 7 is the biggest. Now, I just use my straight up brain to do that. If you struggle, you need to use a number line. So here's 0. 1, 2, 3, 4, 5, 6, 7. I apologize for those noises. They're doing maintenance. 1, 2, 3, 4, 5. Here's -5. 6, 7, 8. All right, let's plot them. -5, right here. 6, right here. 7, and -8. So you can see the numbers are in order from least to greatest now. Left is least, right is biggest. Hello. So -8 is going to be the smallest. We got that right. Then -5, we got that right. Then 6, and then 7. So they're in order from least to greatest. So you can either use your brain and just go intuitively, or you can use a number line. What you looking for?
We're just checking all the doors, making sure they're working.
I will tell you my door last year. Sorry, guys. Just hang tight. My door last year, when we were lined up, a kid pulled on it and we got locked in. My door handle pulls apart, and when it pulls apart, we can't get out of the room.
Yeah, okay.
So,
I'll check it, make sure it's tight.
just letting you know about that, because it was terrifying being stuck in the room when we were supposed to go to lunch with a bunch of hungry middle schoolers. All right, guys, let's keep going. So this one's the same thing. So we want to write them in order from least to greatest. And it's going to be harder to put these on a number line because the numbers are much larger. But you can still visualize it if you want to using estimation. Left is least, right is going to be your bigger numbers. So pause right now and see if you can figure this one out. Okay, so here's 0. 0's in the middle. Let's deal with our negatives first. So our negatives, -35 is backwards the most. -35 is backwards the most. -32 is backwards, but not quite so much. When you count forward, you have 34 before you hit 43. So I estimated with a number line to put these in order. I didn't do every tick mark. So in order from least to greatest would be -35, -32, 34, and 43. Okay, we're nearly done. Erase, erase, erase. I wish there was a clear all feature, but there's not. All right, let's see what's coming up next. Okay, we're on the last part. The last part is to use integers to represent real world quantities. So here's a picture of something that happens in the real world. Airplanes fly in the sky. The airplane is represented by 10,000, I guess, feet. 10,000 feet. That is a positive integer because it's above sea level. That's how we measure kind of altitude. Okay, the airplane flies at 10,000 feet above sea level. Sea level is going to be our 0 on the number line. Okay, it's what we measure things from. Is it above sea level or below? This whale is swimming below the surface at 10,000 feet. So it's negative 10,000. So words like above mean positive, below means negative. So what we have to do is we have to make sure we know lots of key words that mean positive and negative. And I'm actually going to add to this list and post it on Canvas. But words like gain, you gain weight, that's positive. You lose weight, that's negative. You gain yards, positive. You lose yards, negative. Up, down, more, less. In the money world, when you deposit money, you add money to your account. When you withdraw money, you take money out. So for the sake of time, I'm not going to list a bunch more right now, but on Canvas I will post it. So you have to know key words that mean positive and negative. So you guys are going to try this. So if you have a score of 10 points, do you think that's going to be positive or negative? Well, if you score the points, you're adding points to it, so it's positive. 8 steps forward. If you're moving forward, that's positive. You're not going backwards. Backwards is negative. Let's see the next one. Opposite of 7. Well, the opposite of 7 is a negative 7. Not positive or negative. Guys, there's only one number that's not positive or negative, and what number is that? Not positive or negative is 0. Whoops. Okay, let's go to the next one. Trying to click it. A loss of $14. I did 2 at a time. A loss. If you're losing money, that is negative. If you lose money, it's negative. 2 kilometers below. Below is going to be negative. And withdraw. Withdraw is when you lose money. Okay, you're not losing it. You're taking money out of your account. So when you take money out of your account, taking it out means negative. You're subtracting it out. And that was our goal today. Now, when you check Canvas, you're going to see your assignment. Your assignment is in Solvus Realize. You have problems that are very, very simple and easy. You have to identify opposites, and you also have to plot integers on a number line. Okay, so this video was long. I'm so sorry, but it was a pretty lengthy topic. I hope you have a wonderful day. Goodbye.